Okay, welcome everyone to class 5 of Lawfare's hacking course. I am Scott Shapiro. I am joined as always by the amazing Sean O'Brien. And we are going to start networks today, and we are going to finish with DDoS attack. But before that, Sean is going to bring us up to date with the amazing response with regard to the scavenger hunt. So, Sean.
Great. Thank you, Scott. And thank you all for participating in the scavenger hunt. I am showing right here the latest instructions, and we've got so much wonderful feedback around the scavenger hunt. We've had so much great activity in folks uploading their submissions. Scott and I are really blown away by the fact we've got a little over 30 submissions so far from the cohort, so that's really great. Yeah, so we've had such great feedback and such great interaction and activity from everybody. So it's been wonderful and really surprising to get so many people involved. As some of you know, there were some issues with the activity. One of them I want to point out, which is really central, was we did make an error, and by that I mean I made an error at the last step, of course, or the second to last step, of bundling up your goodies, the actual things that you got off of that machine to upload to us. So in this step here, where we have sudo tar cvzf, I originally, in the original instructions, left out the Z, okay? And what that means is that the package is still fine. You know, the package that you sent to us will still be able to read, and we'll still be able to make sure that you have, you know, the pieces that you gathered from the external machine you connected to in that package. But it will actually not be compressed as a gzip. So that may have created some confusion when you then go back to look and triple check that the files are, you know, what you expect them to be. So now that's fixed. I'm going to be updating in the Git repo. I'm going to make a few other little changes too, just for like some clarity and so on. You know, there are places, for example, when you write these kinds of instructions where we might have used like the word you, and folks are like, well, what do you mean by you? Do you mean the user I started with, or the user you had me create? And, you know, that sort of thing. But the really amazing thing is, look, anyone who participated even got halfway through these instructions, you all have connected to a remote machine, you've gathered information from it, you've thrown it into, you know, a payload that you can then grab and send to us. And that's really amazing progress. And here we are, you know, now in week 5, but we were in week 4, and you were able to do that. So congratulations on getting that far. We'll be figuring out exactly how we're going to do, you know, sort of prizes for this sort of thing. You know, we have, you know, as Scott said, many submissions. It's been so much fun just seeing these tar balls just kind of fill into this Dropbox and see how many people have submitted. And there's still time if you haven't completed it, if you needed a little bit of help, if you got, you know, stuck on that step that I outlined. I believe it was step 25. There's still plenty of time to make changes and submit to us. And we'll figure out a way to, you know, choose the best submissions to give some sort of prizes, both physical and digital. And I've got some good ideas on that. So stay tuned on that. And yeah, that's pretty much it for stuff to recap. I think we're ready to go with this week, which is going to be all about networking, and we're going to do a DDoS at the end of it. So,
okay, fantastic. Networks. So, as I said last class, this course is divides into thirds. The first third occurs within the host environment, within one machine, learning the Linux command line. Now, the next third is going to be networks. And then the next third will be applications of the stuff that you've learned, Linux and networks. So let's talk about what networks are. What is a network? A network is an interconnected set of computers known as hosts or nodes. They are connected via links, okay? Network traffic follows rules known as protocols. So when people talk about protocols, they generally mean rules about communication. In the context of networks, we're going to be talking about two main protocols. First one, I'm sure everyone has heard of, Ethernet. And the second one is TCP/IP, which we will talk about next class. Okay. Now, this is something I'll be harping on a bit later on too, but I want to kind of distinguish between what we've been doing, which was we've been operating within a multi-user environment, but within one machine, one host. Okay, so you can have multiple people communicating with each other, but be in one host and therefore not be on a network. So when we've been operating within our virtual machine, we've not been working on a network. We've just been dealing with one machine, even though we've created multiple users. Okay. Now, why would you have a network? Well, two basic reasons. One is communication, email, messaging, all the stuff that we use computers for, and also to share resources. So if you have a shared drive that the members of your team use, or a Dropbox, or a printer, kind of bunch of computers share a printer in an office, that is why you would have networks. Okay. Now, there are two main types of network architectures: client-server, and peer-to-peer. Okay, we will mostly be talking about client-server models rather than peer-to-peer. Let me first talk about what a client-server model is. Think of the example when I talked about the kernel. You're a customer in a restaurant, and then you give your order to the waiter. Okay, the waiter is the server, and you, the customer, is the client. Okay, so the client makes a request and the server responds to the request. Now, we'll be talking about client-server models because that is not exclusively, of course, for those who remember Napster and other types of peer-to-peer, BitTorrent, and there are lots of peer-to-peer stuff on the internet, but basically it's client-server, at least for our purposes. So when you go to a website, your web client, your browser, goes to try to fetch a web page from a web server. When you get email, you get it from an email server, yada, yada, yada. Peer-to-peer is a kind of a different model. There, all the information is not stored in like one place or replicated, but the information is kind of broken up, and your local neighbors may have some of it. Your other neighbors may have others, and you may have to go farther away to get all of it. We won't be talking about peer-to-peer, but just want to mention that. Okay. Servers. Sean knows that this is like a what's the word? So I harp on this a lot. So like server can mean lots of different things. Okay. One thing that it can mean is the software, the application, the code that actually provides the client with the request, with the information that was requested. When Trump used to, go on and on about the server is in Ukraine. If you think about the server as like an application software, it's kind of ridiculous to say the application is in Ukraine. What he meant is that the machine that runs server software is in the Ukraine. But why anybody would care where the machine was is anybody's guess. But the idea is that the server can either be the application, the software that's running, or the machine on which it is running. And also sometimes servers refer to machines that are specially designed to serve. You know, these are like server racks, and you've probably seen you know, on TV, you know, big, you know, black rooms with blue lights, and just racks and racks and racks and racks of these servers. They are there because they're really good at responding to client requests. Okay. This is stuff that none of us ever care about anymore. This is what's called network topologies. There's all different kinds: bus, ring, star, all this stuff. I put it on the slide because maybe you want to know about it, but it's not a real, it's not really important for our purposes. Okay. Types of networks: local area networks called LAN. So like your home network is going to be a local area network. A WAN, a wide area network. So Yale University would have a WAN, a wide area network. And of course, then we have the internet, which is a network of networks. So this class, we're really going to spend our time just talking about the network part of it. And then next class, we're going to be talking about how those networks are linked together using TCP/IP to create the thing we know as the internet. Okay. Now, if you have a network, you are trying to share resources, find a server, route information to another host on the network. You need an address. You can't just drop a letter in the mailbox without filling out the envelope. So you need addresses for messages to find their way on networks. And there are two main address schemes that we'll be talking about. Today, we'll be talking about MAC addresses. Sean will walk us through that, media access control addresses, which every hardware, your iPhone, your desktop, your laptop, they all have their MAC addresses. And then we have the IP addresses, the internet addresses, and we'll talk about that next class. Okay. Common Ethernet technologies. Okay. I'll go through this quickly. A hub, you know, rarely used anymore, but it's like when a signal comes into the hub kind of sprays it out across the network. Whereas a switch does it smartly. It distributes the message in a smart way. So if the message is addressed to me, the switch will direct that message to my machine. And so let me just show you this. This summer, Yale was upgrading its IT, and there was this guy replacing the switches in the switch closet. So I got a picture of the switch closet. That's all the stuff coming in and then being redirected to the machines on the third floor of the Yale Law Building. Okay, routers route packages around a network. Firewall filters traffic, and it can be set up at different points in the network. And a media converter is something that takes something in one medium and converts it to another. So the thing that we experience the most is the wireless access points, you know, those kind of white domey things that you see on ceilings. And that takes the cable, the messages on the cable, and converts it into Wi-Fi. So it's a media converter. Okay, and this is the switch. Basic security issues having to do with networks is, number one, capturing traffic. And this is what we're going to do next week. We're going to do packet captures using Wireshark, PCAPs. Somebody can take control of the network. Somebody can person in the middle it, get in the middle and therefore intercept messages. They can redirect messages to the wrong parties. And of course, they can deny service or engage in a distributed denial of service attack, which is what we will do today. Okay, so I'm gonna turn this over to Sean, who's going to show us how all this works in practice.
Okay, thank you, Scott. We're finally getting into the nitty-gritty. You all, of course, have already done a little bit of networking with us, right? As part of the homeworks, as part of the activities, certainly as part of the scavenger hunt. The major component of that was connecting to a remote machine, grabbing some stuff off of it, downloading it, right, off that machine, and then uploading it to us in our Dropbox, where you get your wings, right? But we're going to go through some basics here. So apologies for the folks who may be familiar with some of this stuff, who may have had some experience with this stuff throughout their professional career. But we're going to go through some very, very basic stuff. And then we're going to sort of ramp that up towards the end into this thing called a DDoS attack, which we can all participate in safely against a server that we've set up, of course. Okay, great. The first thing you need to know is that in your Kali machine, and you can follow along with me from this point, you need to know your IP address, right? You need to know your MAC address. You need to know this information that Scott was just talking about your virtual machine. And your virtual machine is, on a network, even though it's represented, virtually, it's representing itself to a router, as its own machine right now. So if I type ifconfig and hit enter, I'm going to get a bunch of networking information about the machine. Now, if you recall, when we did this in DOS last week, was that only last week? Yes. We used the command ipconfig. So on a Windows machine, that would be the command that you use. But on most Unix-like, Macs, Linux machines, and so on, you use ifconfig, the if standing for interface. So what does interface mean in this context? Well, it means basically the physical representation of the network card, let's say, right? And that's ETH0 here. So ETH0 meaning Ethernet 0, and we're hackers, so we count 0 through 9, right? So 0 is the default. That is your Kali Linux networking card virtually, okay? And the thing you need to know here, of course, is the INET address, which is right here. Now, we're not going to go into specifics. We'll talk more about IP addresses next week and certainly going forward. But just know that there are reserved addresses for local machines, right? And you'll see often 192.168.1 is reserved for a local network, right? So if you have a router at home, as I do, and let's say it goes out to Comcast or some other ISP or Yale or whoever, locally that can be represented by this string, 192.168.1. I have, a cell phone connected. It might be 1.2.3 for, some server that I set up at home, or I know you're not all setting up servers, but hopefully you will. So that's a range you should get used to seeing, but recognize that when you see this, you're talking to something on your LAN, L-A-N, your local area network. Okay. Now, the second thing you need to know, you don't have to pay attention to this INET v6. We won't talk about that right now. Those are future-ish IP addresses. The most important thing for this class today, and the thing we're going to be doing, is looking at this thing called a MAC address, Media Access Controller, your hardware or your physical address. And here it says Ether, and it has this sequence of 2 digits followed by a colon, 2 digits followed by a colon, etc. This is hexadecimal. You'll see this format. Okay, that is baked into, so to speak, your hardware, right, on a normal device. So let's say I have my cell phone and I connect to like a coffee shop, right, with my cell phone. I connect to the Wi-Fi there. I'm broadcasting the MAC address, the baked in hardware address of that cell phone on that motherboard, on that chipset to that router in that coffee shop. Okay, or if I connect to a university network or a work network and so on. And this is the way, on a very basic level, that there can be some access control. That's why it's called media access control, MAC, right? There can be some access control over devices identifying themselves on the network. Back in the day, right, you would have these addresses locked down, and you can still do that at home if you have control over your router. You can say, hey, I only allow these 10 MAC addresses, right, ever on my network. Good luck adding new addresses, or having a friend come over and use your Wi-Fi. That can be hard. But the point is, this is a base level of sort of controlling access to your internet, to your network in general. Okay. Now, as much as that's a good thing, right, to have an address that you can identify individuals, these, or not individuals, devices, unfortunately, they're too often tied to individuals. Those numbers are also really, really predictable in the real world. Vendors don't use random MAC addresses, right? So if I'm Broadcom or Cisco or, all these companies that I'm showing you now on this list, I use predictable sequences of MAC addresses, right? And this is a PDF that I just grabbed off the internet. This has, 371 pages with thousands of entries. And you can basically guess what kind of device someone is using, or if they're using something weird that you don't want on your network, et cetera, based upon that MAC address. So it's way too much information. It gives a lot of info to the router. And it's one of the ways, for example, the stuff we do at Privacy Lab at Yale, we point out that people can be followed around, let's say, a city as they're moving through if they have their Wi-Fi on based upon these addresses. So it's something to be cognizant of. Luckily for us, we're going to learn how to switch that, at least in our Kali machine here. So I'm going to clear. Yep, if I can type it correctly. And I'm going to use something called MAC Changer. Now, MAC Changer is by default on all Kali Linux installs. It's a really good utility. You can install it on other Linux distros as well. And there's something similar you can do on Android devices as well in the settings. Okay, so first thing we're going to do is we're going to type MAC Changer. And we're going to do as it says here. And we're going to type --help and hit enter. And again, that help switch gives us all the settings, options for the device. So the command is MAC Changer, these options, and then the device. This device is that interface. So in this case, it would be ETH0. Okay. And the first thing we're going to do is we're going to set a fully random MAC address. So we're going to type, and in this case, we need sudo because we're changing something low level about networking on the machine, right? MAC Changer. So sudo space MAC Changer. We're going to go random. So -- random space, and then ETH0. And we're going to hit enter. And we're going to type our sudo password as we have to. And bam. So current MAC, Cadmus Computer Systems, right? Permanent MAC, that's what it is. Change to new MAC address, some random MAC address, right? That's the basic way that people can change their sort of identity at this very low level for the device they're using. And you can actually set up MAC Changer to be running in the background all the time, cycling through random addresses as you go through the world. Now, if you do that, you're going to face some issues, right? Because you're constantly representing yourself as a new machine, as a new device, person, etc., to networks as you move through the world. So just be aware that doing this, makes you a new person to a router, right? And that can change your networking situation. It is one of the low-level sort of basic things that without a lot of tech skills, folks can do to sort of hide or at least try to mitigate, people detecting them as they go to coffee shops and so on. It unfortunately is something that's used often by organized crime. It's been used by terrorists. Al-Qaeda had this information in a manual that they were distributing about changing MAC addresses. If you show up somewhere really quickly on public Wi-Fi, you do a bunch of stuff, and your MAC address doesn't identify anything about you or the device you're using, then you can hop in, hop out, and then, of course, do some damage in the meantime. So it's something to know about. But there's an activity called war driving as well that folks at least used to do a lot more, driving around, especially big cities like New York, connecting to public Wi-Fi and then doing some nefarious things. And one of the first things they would be worried about certainly would be making sure their MAC address didn't dox them when they were doing that. Okay. Now we need to do some other activities on the network today. So we're going to go back to our permanent MAC address. How do we do that? We do sudo, we do MAC changer again. And this time, instead of random, we go back to our permanent address, right? And we go eth0 again, enter. Now we've gone from our random address back to our permanent one. And yeah, that's pretty much the basics of MAC changer. Cool, wonderful. All right, so that's the basic stuff about changing your hardware, your permanent address. Now we're going to show you how to communicate, and starting with the most basic version or method of communication to a remote computer via this thing called an IP address or a logical address, right? And I know you did some of this during the scavenger hunt with something called SSH, but we're going to use something completely insecure from 1969, if you can believe it, called Telnet. And it's still around. People unfortunately still use it on insecure machines, and lucky for all of us, I've set up an insecure machine for us to do this on. So the command we're going to type is telnet space 89. So this is an IP address, 147.108.156, right? So 89.147.108.156. We hit enter. And okay, now it's going to ask us for a prompt. This machine, again, is very insecure, so we're going to log in as root. And the password is root, all lowercase. We should be able to all log in at the same time. I'm hoping we will. Okay, cool. So I'm in. I hope quite a few of you are in, if not all of you who are trying it. I tried very hard to lift any restrictions on the network here and make it easy. Okay, now you can see we're root at demo web server 01. We're connected on the other side of the world in this case. Again, I use a wonderful and very patient Icelandic host who doesn't mind me doing these things. And we're in this web server. Now, Telnet is like the most insecure thing you can use, but it gives you all the stuff that SSH gives you. It gives you all of the commands that you can run as this user root on this other machine. And it does it in an unencrypted way, right? So this is going over the pipe, in the plane, in the clear. If you're an intermediary, like that person in the middle Scott mentioned before, you can see this happening over the pipe. Okay, so you saw root as the password as it went over the internet pipe. So that's a huge problem, obviously. But this is the primary way that people connected to servers for a very long time, especially before we sort of figured out standardization of encryption. It's not like we didn't know that encryption existed, right? But we just had to figure out the ways to sort of do it. And there's, all of the wonderful battles that people have over the best way to do things, of course. Okay, so if I do ls here, I'll get, a hello world.txt. And if I wanted to, cat, hello world, I could do that. And then I see it says hello world, et cetera, et cetera. Now let's exit this. We killed that connection. We're back to our Kali connection, prompt that should be very familiar with us. Let's try connecting in a secure way, right? So we're going to do that thing we did for the scavenger hunt. and you probably have seen us do for other exercises, SSH, secure shell. So this is like an asymmetrically encrypted version of Telnet, where we have a key we're identifying ourselves with, and there's identification on the other end, and then you come up with a session that's encrypted, right? You encrypt the session that you're connecting to. Okay, so SSH space root at, and then it's the same IP address, 89.147.108.156. We hit enter. Now password's the same, root, and bam, pretty much the same view, right? We type ls, we get our hello world, we type cat hello world, we get hello world. Okay, we know that works. Cool. Now let's exit that as well. That's the preferred way to do things, right? SSH. And we can talk more about keys and so on further down the line, like better ways to authenticate yourself than like root and root. Not a good idea, right? Okay, let's clear this. Now, we use this as well in the scavenger hunt. This is sort of an easy way to download a file. Now that we know that this machine exists, we know there's a file called Hello World on it. How do we get that file onto our local machine from the remote server very easily? Well, we can use something called SCP, which actually uses that secure tunnel, but it's sort of a discouraged way of doing things these days. But it does work, and in most cases it will work for you, especially if you break into some machine, right? We're going to do SCP space root at 89.147.108.156. Then we put a colon in. Now we're putting in where on the file system we're grabbing this file from. We're going to grab it from, actually we saw it in /root because that was our home folder for root. Then slash hello-world.txt. And we're going up. What did I do here? We're going to do space. And then we're going to put it on our local Kali desktop. What I was trying to do was minimize my Firefox. Okay, cool. So we'll do tilde/D desktop. So we're going to download hello world.txt from the root folder on the remote host to our local machine onto the desktop. And we're going to hit enter. Now we do root for the password again. And bam, there it is. Look at that. And this is so fun to see stuff populate in the GUI. Double click on that, hello world. So you got the file. Okay, now let's remove that file from our desktop and let's grab it one more way. And again, this is just to make sure we're reinforcing here different ways to kind of grab things off of remote machines. When you do your hacks at the end of the class or towards the end of the class, this will be an important skill to have. So let's remove that hello world from our desktop. And now we're going to grab almost the same exact command, except we're going to go all the way back. So I hit the up arrow to go through my history there. And we're going to change SCP to SFTP. And we're going to hit enter. Now, same thing, root. Now, this is the preferred way, believe it or not, to grab files in this day and age. And there's a couple of reasons for that we don't have to get into, but it's sort of the standardized thing. And look, somebody was smart enough. In the meantime, thank you, whoever did that. I can't see the chat. To add a line to the file. Nice job hacking. It says, hi, Scott, in there. That's great. Nice active feedback. Beautiful. Cool. All right. And the last thing I just want to show you in Kali really, really quickly is that last line, that SFTP line, is useful in the graphical environment. So if you open your folder here, so you click the folder up here, and then you open it, and you can click any folder in Kali to do this. Then you hit Control-L, and this little address bar, which is like a browser address bar, opens. You can go SFTP:// root at, and then you put in your server, 89.147.108.156. You hit enter. I'm going to say remember forever here. This will save in a key ring, so you don't have to enter it again. Root. Of course, after today, I'm going to kill that, but it's good for now. Hit connect. And Bam, you get a graphical environment. So you're now connected to this remote server. You can browse through root by clicking, and you can see for yourself, hello world here, and drag it to your desktop. So that's a good thing for you to know as well. You see it here just like a disk, basically. Okay, that's plenty for now. Thank you for your patience on that, and back to you, Scott.
Thank you so much, Sean. Lots of times you hear the term exfiltrate, like exfiltrate, the Russians exfiltrated data. So that's what Sean was just doing, using secure copy, using SSH, using secure FTP. In a couple classes, Sean's going to show a really cool way to exfiltrate using onion share. So there's lots of ways to exfiltrate, and you will be using it for your hacks. So, but we will be going over this, a bunch of times. So, so don't worry if you didn't catch all of it right now. Okay, let's go back to the CIA triad. So, confidentiality, integrity, availability. When we do denial of service attack, what we're doing is we're essentially attacking availability. We're trying to stop some user from accessing information by exhausting their resources. Okay, and so that's what I want to talk about denial of service and DDoS, and a little bit about the history before Sean moves on to actually doing it. So the first thing I want to say about denial of service is you don't need a computer to DOS, to deny somebody service. 9/11 was a huge denial of service. There's like an ISP by ground zero, and internet access got thrown off for a lot of people in Lower Manhattan. So bombs can deny service, you can drain somebody's AWS account of money, and then they can't access their data on the cloud. So the idea that like you have a large botnet that is sending requests to some resource and exhausting it, that's one way of denying service, but there are physical ways of doing it. There's financial ways of doing it. There are multiple ways of doing that. Okay. So like Mafia Boy wasn't the first one to engage in DDoS. So I know we all know what DDoS stands for, but it's a distributed denial of service attack. Distributed in the sense that you have more than one computer sending requests to a server to exhaust its resources. Okay, Mafia Boy was actually, I think he was 17 years old at the time, and he got access to 48 university computers, and he got them synchronized. He made like a primitive botnet. I'll talk a bit more about a botnet in a second. Mafia Boy was able to take down CNN, eBay, E-Trade, Dell, Amazon. Amazingly, he took down Yahoo. That's like somebody taking down Google, like a 17-year-old boy taking down Google. At the time, Yahoo was the largest search engine. So and President of the United States, Bill Clinton, named Mafia Boy, who was 17 years old, as a national security threat, and there was a big manhunt. And nobody knew Mafia Boy's name for a while because he was a minor, and so people couldn't say what his name was. Okay, the DDoS attack that maybe is the most famous is the Russian sponsored, involved, condoned, it depends on who you talk to, attack on Estonia. In the capital city of Estonia, in Tallinn, there was a controversy about removing a Stalin-era statue of a Russian soldier, and people wanted it removed, and this caused a local, then regional controversy, and hackers DDoSed Estonia for 3 weeks. Estonia is a very, even at that time, was extremely connected digital society, so it was kind of not great for them. And because it happened in Tallinn, the law of war for cyber is called the Tallinn Manual, after Tallinn, which some people think was the first act of cyber war. Okay. I've been in a DDoS on October 21st, 2016. Maybe you remember it. At least people on the East Coast could not get access to major websites. People thought at the time that it might be the Russians. It turned out to be, teenagers. This turned out to be what was called the Mirai botnet, a botnet, bot for robot, net. That is that these computers which have been taken over are coordinated and send launch attacks simultaneously or in stages, and so you harness the power of lots of computers against a small number of servers. In this case, the botnet attacked the DNS system of a company called Dyn, and nobody could, people's browsers could not resolve the domain names into the IP addresses, and we will be talking about how DNS works in a couple of weeks. Okay, the reason why I'm talking about this, not only because it's really kind of cool, and by the way, I write about this in my book coming out next May. It's an amazing story, but this is the botnet. By the way, there were at the time DDoS services, so you would pay like $30, $40 a month, and you would get a certain amount of DDoSing that you could use to attack whoever you wanted to attack. Now, Mirai worked by taking over what is called IoT devices, Internet of Thing devices like smart toasters, DVRs, security cameras, things that are attached to the internet, these objects that talk to each other rather than talk to us. Now, it turns out that these IoT devices were running Telnet. And so Mirai first logs into Telnet and breaks the password scheme using a dictionary attack. What was it? Last week or 2 weeks ago, John Hawkinson asked at the end of the class a very reasonable question, like, why are we learning about these things when lots of this technology is obsolete? And the point is that these are basic, and that's of course right, like a lot of the types of cracking that we showed you. It's not going to work on a well-defended machine, on a well-protected machine. It'll only work on an insecure machine. But these IoT devices were really insecure, and they were the Mirai people were able to assemble a list of usernames and passwords by using Google. They just Googled the manuals for security cameras, DVRs, and they got a list from the manuals, the username and passwords, and then just brute forced these IoT devices using Telnet. So Telnet and dictionary attacks, two things we've just taught you, took down the internet October 21st, 2016, which I think is kind of cool. Excuse me. Taking down the internet is not cool. And I know Sean will say this, but do not use this against your enemies. It really is a federal crime, and it's a bad thing to do. Do not do it. We are teaching you this so that you understand how it works, but please do not do it. Okay, so I am going to switch this over to Sean, and Sean's going to take us through our first DDoS attack.
But a few things I just want to say up front. Of course, yeah, we need to be very careful even while we do this exercise. We've set up a machine specifically to take it down, right? So, you know, make sure when you're following along with me, that IP address, that identifier, you enter it correctly, okay? You want to make sure that you actually do that. Okay, the first thing I'm going to do here is I'm going to, let me get out of this, hold on. I'm first going to show you the website that we're going to DDoS, and this is a favorite fan site of mine. I confess, I go out to these fan sites. You know, this is a big one for me. Kind of a big deal here that this site exists, and it's unfortunate that we're going to take it down. Okay, but we will. So Scott Superfans, you know, great group of fans here. As you can tell, they have great aesthetic taste. This site we are going to attack. And this is at that IP address that we had before. So if you pop that IP address in 89.147.108.156 into your browser, you should see all of this great modern design on your machine. Okay, now let me go back to the actual terminal, and let's take this thing down. As we said before, you know, on the internet you can be off-grid, so to speak. You can hide who you are. Attribution can be really hard for cyber attacks. In this case, we're not showing you any of that yet. We will be showing you that as we move down the line, as we learn more complex concepts like Tor and go through the dark web and so on and so forth, the thing called the dark web by people. But in this case, again, keep in mind, you are going to be very, quote unquote, vulnerable as an attacker. If you were to participate in a DDoSing operation, and most people who do participate, let's say the quote unquote script kiddies, the teenagers, let's say, or college students who participate in this sort of thing, when Anonymous was a big deal and they were doing this all the time, those folks were just identifying themselves with their IP address, often with their MAC address to the local router, just not really caring, because there were so many folks participating. They sort of were hiding behind as part of the crowd, right? But individually, they were very easy to find. With all that said, we need to just triple check, and you should do this before you even try to do what we're about to do. Do if config, please, and hit enter. Make sure that you actually set back your Ethernet address to something that looks like this. Generally speaking, on these Kali virtual machines, you're going to have 08:00. If it seems more random than that, it's like D2EF, whatever. It probably did not get set back. And what you need to do is run that MAC changer command, MAC changer -- permanent, right? And then ETH0 and hit enter. Oh, and you got to use sudo, because that's a big root E thing to do, right? Okay, cool. So in my case, it yells at me. It says it's the same MAC, and hopefully that's the case for you as well. All right, cool. So now we're ready to go here. The first thing we're going to do is we're going to use sudo. We're going to use a command called service. Then we're going to type postgre, GRESQL, or SQL. And we're going to type restart. What we're doing is we're restarting the database service, or starting it if it's not running already. That is going to load all of the exploits we need to do this DDoSing. Okay. So we hit enter, that restarts. Hopefully that works for you on your end as well. Might take a little longer if it's the first time you've done that, which probably is. Sudo space. MSF console. Now, this is really exciting because this is where we finally get into this thing called Metasploit, which is like sort of the most important tool, I would say, that Kali Linux gives us. Metasploit and Metasploit framework, that's why it's MSF console, is this tool, and I'm going to hit enter while I talk about it, that loads a ton of known vulnerabilities / exploits, and has sort of made them really, really easy for the average user, for someone who's just learning how to do this sort of penetration testing, this sort of hacking, to use them. And this is constantly updated, you know, when there's a new hack or, you know, some new breach or something. The example versions of that end up in Metasploit, along with other things that are really useful, like, you know, I don't know, social exploits, like pretending to be a Facebook page. You know, you can do phishing attacks and all kinds of stuff for your hacks using Metasploit. And I really hope that you look into this in your spare time beyond the homework, especially if you want to do hacks at the end of the semester here. It's going to be really helpful. Okay, now I'm taking a little bit of Scott's steam because he really loves doing Metasploit, but I get to do it today. Here we are in our prompt MSF6. We get a new caret here. Now we have a new line. So we're in an environment in the command line, but it's inside of this thing called Metasploit. And these steps are actually pretty simple from here. We're going to search for our exploit first. Search space SYNFlood. Okay, then we're going to hit enter, and I'll explain what that means in a second. So we talked about TCP IP. We didn't get into detail. We're going to get into detail when we do more networking. But TCP sends these packets, information across the network, called SYNs, S-Y-Ns, and it expects an ACK, an acknowledgement of receipt of those packets from a machine it's talking to on the internet. This auxiliary /DOS /TCP /SYNFlood is the name of the exploit that Metasploit uses to take advantage of this function, this request response communication, to send tons and tons of SYN packets all at once to whatever machine we tell it to attack. And that's how we're going to do our denial of service and bring down this website. Okay, so we're going to go use. And in this case, I actually highlighted and copied it. You can do that as well. I'm going to paste in auxiliary /DOS /TCP /SYNFlood. I'm going to hit enter. Now Metasploit knows, hey, I'm using this exploit. Now I send commands to this exploit specifically. I'm going to go show options to show me. This is very much like the help you would use in your terminal. The ones that matter to us are our hosts. These are the machines we're going to attack, the hosts we're going to attack. In our case, it's only one, right? The port, this is port 80. That's the HTTP port for a website. We don't have to get into that right now. And then the num here matters to us, which by default is no. That would be the limitation on requests. If we only want to send, you know, requests every 10 seconds or 100 requests every whatever, you could put a limit on it. And that would be one way to get around firewall, like rate limiting and so on. In our case, we're going to be very old fashioned. We're going to send as many of these SYN packets as possible. We're going to set our hosts. So set our host, this thing right here, to the IP address of that server that we're now used to messing with, 89.147.108.156. And please, please, please make sure you have this number correctly, you know, down correctly. At least get the beginning part correct, so you're only attacking my Icelandic hosts machines, not some other random thing. Okay, you're going to hit enter. Great. Sets that to the machine you're going to attack. And that could be multiple machines, of course. We're going to do set our port 80. We're attacking a web server on port 80. Hit enter. Our port's set to 80. And now we're going to run our exploit. Anybody who's here now who can do this along with me, please do. If not, you'll catch up in a little bit. But you just type exploit.
Sean, where can you show us the website?
Yeah, I need to actually pull it up. I actually didn't have it at the moment, but yes, you can see it's unable to connect now. So it is already down. Yeah, so this is the website. Sorry. I suppose I messed that up a little bit, but if you go out to 89.147.108.156, you will now see there's nothing. And not only is there nothing, but it will take a really, really long time to try to connect. So yeah, that's the website. So I'm sorry, Scott, I bungled that last piece, but hopefully you can all see basically how this works, right? And on your own, if you want to make this part of your hacks, you know, this is a really useful thing to sort of demonstrate. Of course, just doing a DDoS and just repeating this isn't quite what we're looking for, but it's a very useful component. So cool. All right. Thanks all.
By the way, you didn't screw anything up, Sean. It's just watching the thing goes down is fun.
Yeah. I always, you know, I need to know how to be a better showman, but thank you. I appreciate it.
Thank you, and have a good night, everyone.